There is a 320/240 2.4-inch touchscreen on Nous. The screen can not only display numbers, text, variable information, etc., but also show images. In this lesson, students will design patterns based on the resolution ratio and coordinate information of the Nous screen, and then display these patterns on the screen through programming. Finally, students also need to train a speech recognition model and program Nous to display the corresponding pattern when Nous hears a certain wake-up word. Before displaying on the screen, we need to first understand how the screen displays patterns. Here, we have to mention two important concepts: pixels and resolution. Pixel, simply stated, means a point. Many pixels can be combined to form the image we see. Resolution ratio is used to indicate how many pixels there are horizontally and vertically. The resolution ratio of the Nous screen is 320/240. Based on this information and the knowledge of coordinates, we can determine how to display some basic patterns on the screen. For example, use the center point of the screen as the circle point to draw a circle with a radius of 40. Then, the coordinate information of this center point is x equals 160, y equals 120. In order to draw the two types of concentric circles in the picture above, the programming block in the figure below is required. In this programming block, x and y are the coordinate information of the circle center. Radius refers to the radius of the circle. Fill can choose no or yes, which refers to whether the circle is filled or not. The circle label here is very important. Usually, if we need to draw multiple circles on the screen, we need to fill in different labels for these circles. Since the resolution of the Nous screen is 320/240, we can determine that the coordinate information of the center point is x equals 160, y equals 120. We use the center point of the screen as the circle center of the concentric circles, and set the radii of the circles in the concentric circles to 20, 40, 60, and 80 respectively. First, we display concentric circles with no fill color. Here, special attention needs to be paid to changing the circle label. Compare the two sets of programs in the figure below. When the circle labels of the four circles are all set to 1, only the last circle in the program is displayed on the screen. When the circle labels of the four circles are set to 1, 2, 3, and 4, respectively, the concentric circles will be displayed on the screen. Next, we display the concentric circles filled with color. Special attention should be paid to the order of these circles. Compare the two programs in the figure below. When the order of the four filled color circles is from small to large, the last filled color circle in the program is displayed on the screen, which covers the previous three circles. When the four filled color circles are the order of the color, circles is from largest to smallest, and only concentric circles filled with colors will be displayed on the screen. Now, let's analyze the method of displaying the Olympic rings on the screen. The first step is to locate the coordinates of the center of each Olympic ring. The second step is to set the appropriate radius length according to the screen size and the position of each circle center. The third step is to set the color of each circle. If we want to achieve animation effects when displaying these patterns, we only need to add appropriate waiting time between each geometric figure. For example, the program to realize the animation effect of the Olympic rings is as shown below. Task 1. Students follow the prompts on the worksheet and program to display concentric circles, Olympic rings, truck, and Mickey Mouse on the Nous screen. Task 2. Programming realizes that when Nous sees a certain April tag card, it displays the corresponding pattern on its screen. In order to facilitate program writing, we can first use the My Blocks coding block to make the programs for drawing the above 5 patterns into 5 new blocks. Example is shown below. Use the event block and turn on the tag code detection function so that Nous can see the tag image. Then the recognition result is judged, and if the recognition result is 1, then Nous draws concentric circles. Wait for 1 second and then empty the Nous screen. The same logic can be written for the remaining 4 programs to identify tag codes. In this lesson, we learned the concepts of pixels and resolution. After getting familiar with the coordinate information on the Nous screen, we programmed to display patterns on the screen. Finally, the program was upgraded by combining the April tag recognition to further experience computer vision.